या ठीक है, और क्या हो सकता है? फिजिकली क्या होता है? फिजिकली क्या होता है? You see, we have a problem in hand. I've been told that there are some young scholars who believe that test tube उलट जाती है, जो उसको नहीं, यह भी होता है कि मॉलिक्यूल उल्टे हो जाते हैं. क्या है फिजिकली, क्या होता है? व्हाट एक्चुअली हैपन फिजिकली? लेट्स स्टार्ट फ्रॉम द बेसिक्स, यू नो, क्योंकि अगर ये आज तय नहीं हुआ ना तो फिर मैं कल से दोबारा बनाना शुरू करूँ. अच्छा अच्छा. What actually happened? Reda said that it is the orientation of the spin, which is nuclear spin, right? So what is actually happening that this is the nuclear spin orienting towards randomly in different directions, you know. And when you place them under the magnetic field, spin half nuclearly, then they orient themselves aligned or opposing to the magnetic field. So physically what is actually happening is a physical change in the spin of the nuclei, right? Direction of the nuclei just spins hai. This is the only physical change happening. It doesn't really mean that कुछ और चीज में हो रही है, molecule उल्टे हो जाते हैं, सीधे हो जाते हैं. It's not the case, right? It's just only the nuclear spin which align itself or oppose itself. Achha, let me ask you a question. In a universal picture का मतलब है general picture of nuclei of spin half nature, when there is no magnetic field, क्या होता है? What is actually happening? क्या चीज है? Random orientation है. So random orientation means that the spin is all over, you know. It can have anywhere, all possible direction spin exists. Which one of them align themselves and which one of them oppose themselves against the applied magnetic field? Absolutely. So that is how this actually happened. That among these randomly oriented nuclei, the one which have relatively high energy will go and oppose, and the one which have relatively less energy would align, right? This is what actually happened. And why it is important for you to understand, because you are not giving any energy, you are just giving them an orientation which provide them a sense of direction. ये बिल्कुल ऐसा है जैसे कि very simple magnetism experiment in which you have many pins and they are all randomly arranged. But if you bring a magnet, then you would see them arranging in a very appropriate direction. This can physically happen. You have seen it happening so many times. तो ये होता है. अच्छा, tell me for nuclei which are not spin half nuclei, for instance nuclei which can have 3 different orientations, in that case क्या होता होगा? तीन एनर्जी लेवल्स बन जाते होंगे. एंड इन टर्म्स ऑफ फिजिकल ओरिएंटेशन क्या होता होगा?
कुछ अलाइन होते होंगे, कुछ ऑपोजिटली अलाइन होते होंगे, कुछ दोनों कंडीशंस में होते हैं.
Absolutely. So that primarily means that you can have 2, 3, 4, 5, 6, 7, 8, 9, 20 different orientation, and these are the orientation in which some of them are close to the aligning and some of them are close to the opposing. सही है? So among them the lowest energy would be the one which are exactly opposing. Highest energy would be which are exactly opposing, or the lowest would be which are exactly aligning. But you can have in between various different types of states. Various different types of state, और ये वजह है कि these are called quantized states. And these are quantized states because they all have a defined energy level, and they have a defined energy level, and they have a defined energy difference between all of them, right? And therefore providing energy means moving from one to the other depending on the type of energy. And okay, We discuss induced emission. What is induced emission? You see, there was one question that when you give an energy, then the nuclei which are in the highest, which are in the lowest energy state would absorb and go to the highest. So it means that all of them will go to the highest. No? What happened at the same time? एक बहुत important phenomena which was avoiding, but later I discussed that. आया चले. Before that I ask a question. जी हाँ, मुझे खुद भी समझ नहीं आया. I ask you a question, which is the situation called in resonance.
So when you give oscillating resonance, then lower energy level will go to the higher energy level.
Level तो वह नहीं जाते, species जाते.
Lower energy का जो nuclei है वो higher energy की तरफ जाएगा, तो वो in resonance.
नहीं, in resonance to what? In resonance to incomplete sentence है. In resonance to applied radio frequency, right? In resonance कब होता है? When is the in resonance situation? सब साथ बोलेंगे तो सब पे यकीन आ जाएगा. सजाद, गुड, शाबाश. मैंने दिल तो रखना है ना सबका. Okay, it means that when there is a constructive interference, okay, when the frequency of applied radio frequency matches with the oscillating frequency of your nuclei, then you would have an energy transfer. This is an in resonance situation, but it can happen both sides. It can be a transfer of energy from radio frequency to the nuclei and from nuclei to khatam, finish. The nuclei which are in high energy state will do the reverse, right? They give their energy to radio frequency, and the nuclei which are in low energy state will absorb energy from radio frequency, right? And the one which will give energy to radio frequency will go through a process called induced emission. ये किसी NMR book में नहीं पड़ेगा, मिलेगा आपको, because people generally avoid this type of discussion. वो बड़ा खतरा